So hi, today we are going to talk about databases on AWS. So we'll go through um, databases, a lot of databases which are provided by AWS, and find out some of its features and what are its capabilities, and also how the security is provided for that, and why these are built on what purpose they are built. So to understand, there are there are two fundamental focus areas. So those are like first is lift and shift. So basically, it means that if you already have an existing application and you are building, uh, sorry, if you are bringing that into the cloud, then basically that is lift and shift. And if you are trying to build a new app completely into the cloud, then that's another area to focus. So we will see both aspects of it. So to understand the modern apps, basically now the apps are having a minimum of, or mostly the apps are on an average they would have somewhere around 1 million plus users, and data volumes are growing, and it would be from terabyte to exabyte, and locality is global, and you need to be have availability um, throughout the world, and performance is performance expectation has gone to milliseconds to microseconds. From the expectation is from milli to microseconds, and the request rates are also growing. So you might expect billions of requests per second, and the accessing um, endpoints could be web, mobile, IoT devices, and many other devices which are out there. And these modern apps are have the requirement of scaling up and scaling down, and as well as scaling out and scaling in. So basically it means that a horizontal and vertical scaling. And the economics is uh, you know most of the apps are the cloud providers are pay they are going into a model where you say pay for what you use. So that has become an expectation of modern apps now and cloud providers. So developers has access to no assembly required. You could build everything into the cloud, and um, the expectation or the requirement nowadays is that you don't need to own any infrastructure as such. So here's a article from Werner Vogels. He is the CTO of Amazon. So what he says is that all things are distributed. So if you are building a scalable and you know a robust application, and they are mostly distributed. So he goes on to explain that developers are doing their best to break the complex applications into smaller pieces, and then picking those picking the best tools to solve each problem, each of the smaller pieces problem. And the best tool he would developer would choose, uh, which actually fits into the the problem, to solve the problem. So the key point here is that not all application data models or use cases match the relational models. So we might have uh, different purpose-built databases for different requirements, right? So basically one size doesn't fit all databases. So we're going to explore more of these purpose-built databases and um, understand why and how it is helpful, or what is a need, and let's understand what's the difference between relational database and other databases. So whenever there is a database workload, whenever you consider a data, you would see three things in that, right? So you would see the shape of the data, you would see what is the size of the data, and you would see what is the computation uh, required for your data workload. So either you could choose a general purpose database, which could be a relational database for all the requirements, or you could choose a purpose built database workloads, which is specially built for the particular workload. So let's understand the three factors. So there are the three factors are shape, size, and compute. Let's understand each one of them. So what shape means is the purpose built for whether it's a row or it's a column, or whether it's a key value pair, or whether it's a document store, whether it's a graph store, time series, or it's an unstructured store. So basically, a row store basically means that you operate on a record. Column is mostly they are best suitable for aggregation, scanning, and joins, and they are helpful for analytics workload. Query, key value store is for querying by key and getting the uh, high throughput and fast ingestion. Basically, it can be used for tracking the car location, um, or any IoT devices uh, track, or it can be many other examples. So document store is basically, as the name itself suggests, it indexes and store documents for querying. It can be patient database, it can be employee database, um, and there are graph stores which have, there might be a optimization required for persisting and retrieving the relationship of the data. Then you would use graph store. And sample example workloads are um, a recommendation system, or social networking applications. uh, yeah. And when it comes to time series store, you would store and process the data in sequence, and the best example would be process engine. And it, there can be many other time series data as well, like click um, you know click streams. It could be logs which are being processed. And if you think about unstructured data, it's basically you could get and put of an object. So what would be the best store, or um, basically the example would be store users reviews, or it could be any object which is um, not structured. So you would choose an unstructured store. When it comes to size at limit, then you need to think about what kind of database to choose when you have bounded uh, limit, or bounded size, or when you have an unbounded size. So when I say bounded, example would be the number of employees. So for example, in the company, the employee strength might be 100, It can be 1,000, it can be 100,000, or even 10 million. So 10 million is again still a bounded uh, entity, right? So you know how much max it can go up to. It can go up to 1 billion, but still it's a bounded entity, right? So but there are certain data where you cannot uh, you know uh, have a limit across it. For example, if there is a if you are trying to monitor the um, sensors, IoT sensors data, or let's say you have, if you take an example of Uber, and they are monitoring the car location every second, let's say that. Okay, so the data is unbound, so the location keeps coming up and it can be unlimited, right? So that's what the size at limit means. So you need to choose, you need to consider basically what kind of database should I choose for these kind of workloads. So there can be there can be a working set size, and there could be caching required. So in those cases, what kind of database I would choose? And there could be retrieval size from one row to 10,000 row. And what would, in those cases, what would be the database that suits best here? So you got to consider these kind of size consideration when choosing the database, or when you are selecting the database for your workload. I'm not talking about for the whole project, but for a particular workload. And there is also partitionable and monolithic size consideration. So when I say partitionable, here the example given is storage and processing for car location, which is partitionable. So partition means here basically um, sharding. You could say um, horizontal splitting of your data into different workloads. So do you need that in certain, you might need that in certain situations. So you could consider in those many areas. You also have to you might also have to consider the computation. And compute functions basically means that you might have to sum the sales for last 12 months, or um, get and put datas. Even they are considered as computations. So you might need to consider the rate of ingestion. You might need to consider the uh, change rate, how frequently the data are updated. And the throughput. The throughput is basically like millions of users browsing a Amazon catalog, product catalog every second. So how, how would that be? Whether you can expect what would be the throughput. And you might also consider the latency that it is required for, let's say, to get the car location in 5 milliseconds, or you might need uh, you might have a workload where the latency is doesn't really matter in certain situations. It can be up to seconds or even minutes. So um, you could you could choose these computation capabilities and the uh, size, and you know uh, just a second. You could You could consider all three: shape, size, and compute to determine what suits best for your workloads. So basically, those are used to uh, find out what kind of database would help for consideration, right? So let's understand different categories of databases or data that could be structured so that you could come at a better judgment. So we all know the first and the widely used database is a relational database, and the data is structured in a relational manner where where we get ACID transactions. We have a strict schema. We have referential integrity where tables can reference one another and it's normalized, and such features are provided by relational where the data is bounded. The um, you know computation is scalable, that is, it can be scaled up, and this was considered relational database was considered in the first place to save space, save storage space, and computational capabilities were not considered much at the moment of building this relational database because storage was more expensive. So when storage became more cheaper and cheaper, a lot of other database categories were were added. So some of them are key value um, data database. So basically, this provides high throughput, low latency reads and writes, and endless scale. So this is a perfect example for unbounded um, database. So relational database is an example of bounded database. Yeah, so there can be more read and writes. So uh, sorry, I'm very sorry. It's not more just read and writes, but the amount of data that can move between the systems. So I/O means the number of read and writes, right? So throughput is the amount of data that can move. Okay, it's about the amount of data. Throughput means it can be from the table or to the table. Okay, and so basically the key value pair has three main qualities, right? So one is high throughput, low latency in read and writes, and it can scale endlessly. Okay, so it can have unlimited number of data because the main reason is it the underlying structure would be uh, a distributed system, which we already saw in DynamoDB structure. So since it's a key value store, um, you could see that it could scale endlessly. You could add any number of data and without any bound. But relational databases are not like that. So you select what kind of EBS volume you need. You want 30 GB, 40 GB, maybe 2 TB, 16 TB, or even 32 TB, or if not even 64 TB, right? But 64 TB is still bounded. You have a finite amount of database that you could store, right? So there is always a thing for you to choose when it comes to size and the databases here. So when it comes to document database, so they store documents mainly uh, to have large amount of documents if you have. Yeah, when basically it would be something like pointer to the document, and you would store more of the information inside the document. Probably whenever, not frequently, but whenever required, you could go get the data within the document and query them with attributes. So basically, in those cases, in content management or personalization cases, you would use document store. So there is also in-memory databases where you query by key with microsecond latency. If you are looking for speed, then you would go with uh, you know in-memory database. So if you need more computation capacity or you need less latency, then you would go with in-memory databases. Yeah, I'll get to that, but I'll not spoil the surprise. Anyways, yeah, I'll come to that in a moment. Okay, since you asked, Elastic Cache is one that is offered from Amazon, but the open source examples are Redis and Memcache. So there is also a graph database, which is quickly and where you can quickly create a relationship or navigate between the relationship and find the data required. So basically, social networking recommendation engines, or whenever you want to find out the fraud detection in case of the net, to find the net, basically the shortest path between the two people, two endpoints or nodes, then graph could actually help that. Graph database can actually help with that. So there is also something called as time series database. So basically, this would mostly collect and store the database and also process the data which is sequenced by time. So you might be thinking, right? Why do you need a time series database? We could always go with relational or key value store. Yeah, you could do that, but this time series database is specifically built for um, the time series, right? So it would have uh, its own capabilities to process the data by time. So um, it gives you more advantage where it could process more than 10 million records uh, by within a second, right? It can take in, you can ingest 10 million records into the time series database, and you could get the response across these huge volume of data with a very less amount of time. So time series database is used when you want to process the data which is sequenced by time. There is also a ledger database. So this was required because if you want some immutable data to be stored, then this would come in handy, where the history cannot be undone at all. So any data that you write that goes into this database is not erasable. It will exist forever, right? So if you, yeah, probably I'll explain ledger in a later slides. So the example for that is any systems of records, supply chain management, healthcare, registration, and financials. So they all come with some compliance, and ledger database provides that compliance um, such that in financial, let's say in financial or registration purpose or healthcare, uh, the data cannot should not be erased when it goes back in time, right? So it can be, any data can be updated, but the old data should not be erased. So that would come in handy in such situation. So these are some of the database categories, and let's find out what AWS offers for these categories. So the purpose-built database offered by you know um, AWS is um, for relational they provide RDS. For key value store and document they provide document DynamoDB. There is also a database called DocumentDB, which is a MongoDB version of um, you know version of AWS variant. So which you could use for document database as well. But in any case, you could use DynamoDB for document store as well. And for in-memory database, Elastic Cache is provided. So you could use Redis or Memcache. There is Graph database, and AWS provides AWS Neptune. And for time series purpose, AWS provides time stream, and for ledger database, it provides QLDB database. So let's see what are the some of the differences between SQL, NoSQL, and Graph. Quickly. So SQL is optimized for storage. NoSQL is optimized for compute. So whenever you're thinking about storage, um, think about SQL. So you have data where um, it has to be normalized, which is relational. And if you think that you have you have to optimize the data for storage, then you could think of relational databases. But if you think of a database which needs to be fast and which needs to be optimized for computation, then probably you should think about NoSQL databases. And if you're thinking about workloads, such as there is a lot of relationship between these workloads, then you would basically choose Graph database, right? So the key differences is SQL is normalized relational database, and though NoSQL is relational, but there is no relation between the rows of the tables. So the values, the rows are denormalized, document is denormalized, and in Graph database, the entities relationship is denormalized. So SQL and Graph database both provides ad hoc queries, but for NoSQL database, you need to instantiate the view and need to provide the computed aggregations so that it can give you the results faster rather than computing the results at ad hoc, right? So the SQL database scales vertically and NoSQL's database scale horizontally, and Graph database does both. It can scale vertically as well as horizontally. So these are great for OLAP and DSS, and NoSQL database is great for OLTP and DSS at scale. And these graph databases are designed for graph traversal. So let's understand what graph database really does and how it helps us in finding the how it can optimize uh, with the help of relationships. So basically, in graph database, relationships are first-class databases, first-class objects, and basically they are identified by vertex and edge. So vertex is the node and edge is the basically relationship here. So here's an example of product recommendation to the user. So this is written in Gremlin language, and this is the Gremlin language is used in Neptune to find the relationship within between the objects. So here we are trying to find the product recommendation for Sarah. So customer who also follows sports, and what they are what are the products that they have purchased. So in this case, Kevin is following sport, and what are the products that he has purchased. We are trying to find out what is the product that Kevin has purchased, right? So if you see this, name is equal to name Sarah as customer is like as is like alias. So out so basically in a relationship you get a direction as well. So it can there are three directions. So basically what it means is like out, in, and bidirectional. So bidirectional is both, you could use both here. So whenever you say both, it doesn't matter whether it is in or out. But when you explicitly say out, it means that the direction of the relationship is from the first node to the outgoing node. So out is the sport here, who's basically you are specifying the relationship here. So if you see this follows, though this is a relationship, as this is the first class object, so you would say what kind of relationship it is. So it is follows relationship. So out is sport, and it says in uh, follows, right? So there are two follows coming to the sport. One is from Bill and one is from Kevin. So it would, when I say in follows, these two nodes are um, considered, and the next out from those nodes are purchased. That should be purchased. If it is purchased, then the next node should be the name, and it is trying to find out the name of the node, which is the name of the product here. And here it is also they in this query they're also deduplicating. Firstly they are taking out the customer, that is Sarah, and there the NEQ is not equal to the customer, and they're trying to find the product here. And in the another case, what they're trying to do is find the recommendation. So who is you know to for the Mary, who is that we can recommend, right? So we could ask for Mary in the recommendation system that do you want to be a friend of Kevin, or do you want to send friend request for Kevin, right? So this is the query that is used here. So it's very straightforward. So as I said, you could give alias. So Mary becomes start here. So when they say both, it means that the direction doesn't matter of the relationship. So it can be nose. So nose is Amit here, and when from that node, it can be bidirectional as well. So the relationship is nose, but so here the value is Kevin. So this is how you write the graph database and easily find out the relationship, or find out the the product recommendation system recommendations here. So basically this is a recommendation engine which would say what is the recommended product for Sarah, or recommended friend for Mary. So graph database, with just one query we could find out all of this. So there are no joins, there are no uh, you know any relationship that is to be built between tables. So this is just in one query you could find out the results. Coming to columnar database, basically columnar databases are optimized for reading and writing on specific columns. So basically they provide high throughput, as I said, and they're ideal for analytics and query performance. They also have reduced disk IO requirement because the way the data are structured are entirely different inside the columnar database. So it is very fast when we are trying to analyze a certain column of data, and because the blocks are placed next to each other within the columnar database, we can retrieve the data fast and process. The disk IO would be reduced and the results can be retrieved faster. This also gives us an opportunity for compressing high level of compression of data, because there might be a repeated number of how the compression works, right? So if there are repeated number of uh, bytes, so those bytes can be compressed into you know into smaller chunks, and it can be decompressed whenever required. So the best example here is Redshift. Redshift is a columnar database here, columnar storage, sorry, and this is basically used for data warehousing workloads, and best suited for any analytical workloads. Moving to in-memory storage, in-memory database optimized for read-heavy workloads. So if you have frequent reads about a certain data, then you could put in memory and the latency would be less, and you could get uh, the response within sub milliseconds. So what it means is less than a millisecond you could find the results, and results are the response would be extremely fast. You could reduce traffic by hitting these backend databases which are out there. Whenever you use, I think you are very familiar with memcache, where rather than hitting to the backend database, we could hit the memcache database and find the results quicker than the loop where we go back to the RDS or RDBMS databases and find the results. So these are ideal for social networking or game leadership boards, and API request limits are, when the API request limits are throttling, and for recommendation engines. So let's move on to Elasticsearch service, where these are best suitable for text search engines. So basically, faceting search allows categorization of search results. Faceting search basically is like if you want to find out particular categories of data within the uh, text, then you could do so. For example, if you have a price range or product types uh, within the text, you could do that to um, this basically is called faceting search. So you could also use for suggestions on your on while you're typing, so auto suggestions in the text areas. This could also help reduce traffic hitting backend databases. Um, so basically, Elasticsearch most of the time is used for search engines where uh, whenever you're searching any particular product or in anything in the catalog, um, you know, whenever you need very fast response times, you could use Elasticsearch service. So if you consider the retail demo applications, there is actually AWS has provided us. Oh, sorry, AWS provided us a sample application where uh, it has a cloud formation template where you could, with just one click, you could deploy this whole application into your account, and you would get all of these databases and the whole setup of a bookstore demo app inside your account. So you could check how key value pair works, how graph works, how in memory is connected, and how the search engine works. Basically, this is available on GitHub. And if you want to know more about CloudFormation deployments or how the resources are allocated, you could always go back to the template and find out what are the resources that are allocated and how it is, and you can just play with it. So I talked about ledger database. In Amazon, it's called Amazon Quantum Ledger Database, QLDB. So this is basically fully managed ledger database, and it tracks and verifies history of all the changes made to your application's data. So I said earlier, it is immutable. So any record that goes into the ledger database cannot be erased back. I'll tell you how or why it is so and how it is implemented. So cryptographically verifiable. So what it means is your data is stored cryptographically inside in the data store, and they are you know uh, cryptographically stored. I'm sorry. Yeah. So basically, what it means is data are stored in the database um, with encryption, and the encrypted data cannot be modified, but it can only be retrieved. So they are highly scalable as well, and it's easy to use. Let's see how it works uh, quickly. So this is a ledger database, conceptual design. So we have a ledger where there are many journals, and each journal will have current and history records, right? So whatever, whenever, let's take an example of inserting a car details here. So whenever you insert a car detail, it would go to current.cast table and also history table. So whenever you update it, the updated record goes sits in the current table, and the um, up, the updated record also goes and sits in the history table. But the difference is the history would always have the data which cannot be updated once written. Then it is cryptographically encrypted and saved in the database, which can't be deleted. So the latest the latest data would be part of this current a table. So whenever you ask for the a Tesla car which is model 7 or with ID 1, you would get the current data. These are just the versions of the history. Whether you delete this, the another entry would be made here in the history cars saying that the Tesla car model was deleted. If you update it, another entry is made whether whatever the attributes has changed would be recorded here, but none of the tab records in this table is are deleted. So as I told, time stream is fast, it's scalable, it's fully managed time series database. So Amazon variant is called time stream. It gives almost 1000x fast speed and one tenth the cost of relational database. So it gives you the rate of millions of inserts per second. So it can give you up to 10 million per second, and trillions of data events can be stored uh, in the time stream. So it can be used for analytics purpose as well, and this is completely you know uh, serverless database. You don't need to provision the server or anything. So it's a great you know database option if you are trying to use time series data. So there is a theorem called cap theorem, probably you would have heard when it comes to system design. So there are always three things: consistency, availability, and partition tolerance. So consistency always means so all clients will have the same data to view. Availability means all clients can always read and write. Partition is basically the underlying network layer. So you, in any certain situation, you got to choose only uh, two options, because you cannot have all three at once. So that's what the cap theorem is all about. If you're trying to find consistency, and if you are choosing availability, you might have to lose partition. If you're choosing partition tolerance, then you might have to choose availability. Or if you're choosing availability and partition, then you have to let go consistency. So this basically defines what kind of uh, database you might need for your workloads, and you might have to consider these. You might have to think about this model to understand which database to choose. There is also something called a spy theorem, which talks about uh, pattern flexibility, uh, infinite scale, and efficiency. Even in these cases, you might have to choose just two options out of three, where it can be either partition and infinite scale. In this example, if you want to understand, infinite scale is we talked about that, right? Unbounded databases. So they are provided by Amazon Redshift, Athena, DynamoDB, um, and there are many other open source databases. So if you're thinking about something about a pattern where that your data has to be structured, and when you if you have to run an ad hoc queries, then you might have to think about RDS here. So efficiency is all about you know the latency for your workload. So you get to choose only two of the three. So AWS databases and analytics, right? So this is the wide range of portfolio uh, where AWS provides their services in. So it could be OLTP databases, it could be OLAP, it could be any business intelligence, uh, you know, it could be a data lake, it could be data movement between, you know, uh, between your on-premises and the cloud. AWS is trying to provide um, services for all of your needs. So since you have such an ecosystem, you could use this cloud service to cater your need and try to be, you know, try to be independent of your on-premise workloads, and you could actually move towards most of the AWS offerings. You could also choose to run your other open source systems in the cloud. For example, if you're choosing Hadoop or Hive or any other uh, workloads like Kafka, anything for that matter, you can still uh, you know use it or run it inside the EC2 and build your own platform. But this is to say that most of it is built by AWS to cater your need, and most of it is built on Apache softwares, and which are basically nothing but open source softwares. So they have modified a little to cater the need. So here's a quick example of Duolingo and Airbnb. In this case, there is DynamoDB, Aurora, um, and Elastic Cache, which they're using. They're using many other services, but when it comes to database, DynamoDB has been used for massive data volume and quick lookups. And Aurora database is mainly used as primary transactional database for user data. And Elastic Cache is used for instant access to common words or phrases in case of Duolingo, and in this case for state, in Airbnb case for session state. So you might have to choose the database um, not as one place to store it, but uh, you could use the data to be stored in multiple locations where you could leverage these databases to improve the performance of your application. So let's understand the Amazon RDS offerings. So Amazon RDS is basically a managed relational database service that is offered by Amazon. So they have a wide range of databases. So there are cloud native database, there are open source database, there are enterprise databases. These are easy to administer and available and durable. They are highly scalable, and um, they provide speed in terms of storage, which is stored in basically SSD drives, and guarantees uh, encryptions at rest or even at transit. So as I told you, there are three variants in the RDS engine. This Oracle and SQL Server are commercial grade and commercial databases, and the open source. In the open source platform, they support MySQL, Postgres, and MariaDB. When it comes to Aurora, they support MySQL compatible Aurora and also Postgres SQL compatible Aurora. But this has Aurora own storage system which is distributed in nature and very different from what these underlying storage has. So these are backed by open source and commercial are backed by EBS volumes. So you have uh, there is a certain limit for these EBS volumes to be stored. So there is always a limit for your database in these environments. So when it comes to relational databases, relational data store as tables, columns, and relationships, and relationships are established via keys. They have strict schema. They have they are usually normalized to minimize duplication. They use SQL as query language, and they scale up in processing. So scale up um, is basically you are vertically scaling, which means that you are increasing the CPU capacity when the uh, when there is a requirement, or when there is when there is more data load for your database. So here's an example for normalized and denormalized database. So for normalized, in normalized database, you could use complex queries, and you could, you might have to use transactions because you might be making changes in multiple tables, and there is, basically this would be read heavy data. And whenever it comes to denormalized data structure, um, it is easy to query, and there would be it would require more storage compared to normalized data, and there will be more duplicates. And but the advantage that you get is, it can be uh, fast in reading, and this is basically typically used for read-only data structures. So there are many variants of engine version. So newly Postgre 11 and MariaDB 10.3 has been introduced, and MySQL 5.5 is deprecated, and Postgres 9.3 has been deprecated. So whenever you're choosing an RDS database, you might have to choose what are the families, um, from which family you need to launch your DB instance. So if you might have to understand the purpose of your data, and then choose the computational size. So out of the three pillars, the size, or compute. So compute here plays a important role uh, while choosing the instance family. So if you are looking for a free tier, I would suggest go with T2 Micro, where AWS gives you a free tier for it. Or if you are looking for a very simple database, you could go with T3 Unlimited, where you know you could set a particular size, and in unlimited mode, even if there is burst, it can take the load, right? So uh, you could go with T family if you have a burstable instance, and you don't have a steady workload all the time, and you're looking for a very small workload. But if you're looking for CPU intensive workloads, then it's best to choose uh, M family. And if you're looking for high number of connections counts, then it's best to choose R family workloads, and you would get more connectivities and memory optimized instances. So your computational will become much faster compared to other two families. So you might be choosing, you might have to choose between um, the two variants, right? So general purpose, which is YAM and T. So there is also uh, provisioned IO where you are looking for more throughput, where uh, you need your need might go up to uh, 80,000 IOPS. In those cases, you could choose between general purpose and provisioned IOPS. There is also a magnetic um, variant where uh, if you just want to store your data in somewhere, then you could use this magnetic database. But it is seen that EWS itself recommends not to use this magnetic because uh, it might turn out to be costly in the future because of other options getting cheaper. So let's understand some of the features provided to relational database RDS, right? So the most important feature is high availability for multi availability zones deployments. So what it means is, if your server is deployed and if you enable multiple availability zone deployments, what happens is there would be a standby system provided to you in a different availability zone. Even if the whole availability zone goes down, what happens is the data can be redirected to the data route can be redirected to a different availability zone where the automatic failover can happen, right? So how this works is you have a database, and whenever there would be a synchronous replication of database in another availability zone that you choose, and your data would be in synchronous uh, replication mode. So only after writing to this database your requests are written back, right? So this is inexpensive and this can be enabled quickly. And whenever your database failure happens, there would be your data route request route is managed by RDS to redirect to the other availability zone database. And this again, since there is one and the requirement you might have set for another instance to be backed up by this database, immediately it could start another instance in the availability zone, in the previous availability zone, or it could be launched in new availability zone as well. But as soon as this goes down, as soon as there is a request redirect to your secondary database, a new that would be actually promoted to primary, and a new secondary database instance would be brought up. And the secondary instance would take some time to brought up, because the switchover would take a few minutes to happen between primary to whenever the failure happens. The switchover is always the downtime might be uh, around around 2 minutes. So there might be some delay. So when it comes to read replica, if you can also have an option of providing a read replica of your application. What it means is uh, you could promote another set of database within your location or within your availability zone, where that database can act as a read-only mode, which can act in read-only mode. But the problem with this is it is synchronously replicated. Hence, if your data is written and at the same time accessed to read, and the data might not have traversed from primary to your read replica, then the data might be stale. So if you are if you are not very much worried about such a consistency or strong consistency, and you are okay with eventual consistency, then read replica can help improve your performance of your application in um, you know in improving the application's performance. So some of the supported databases are Aurora and RDS for MySQL, Maria, and PostgreSQL. Some of the commercial grade uh, are not yet in support. I think they are going to bring commercial databases to uh, help with read replicas as well. I mean, these options are not yet available, and actually they are bringing for SQL Server, and maybe I would add for Oracle as well. So these are some of the differences between multiple availability zones and read replica. You need to understand multiple in when you're whenever you are enabling multiple availability zone option, the replication happens synchronous. In read replica, it is asynchronous, and the content would be eventually consistent, right? So in multiple availability zone, the secondary system is a standby system, will be in idle, it will not be running all the time. But in read replicas, the backend system or replica systems are running. So you could your application could access these read replicas and improve the performance, right? So in multiple availability zones, uh, the systems are always in two different locations, but in read replica it would be mostly in single location, but you could uh, choose it for cross availability zones, or cross region as well. So here in multiple availability zone, database engine uh, upgrades on primary and then on secondary. And in here, the upgrades are independent of primary because these are just read replicas. So in multiple availability zone, automatic failover is issued when it is detected, and in read replicas you have to promote read replicas on your own to say these are the read replica missions, and application let application access it. You have a disaster recovery strategy for you can have a disaster recovery strategy for by establishing both multiple availability zones and read replicas, right? So at any instance of time you could have like four zones of uh, four zone availability or disaster recover option for your data. So you could have multiple availability zones for your um, source or primary database, and also replica database, and also each could have a replica as well. So ultimately you could place your database servers in four different availability zones. You could also use delayed replication for your database. It's not just for MySQL, probably for they could have brought it now this year for other databases as well. So delayed replication is basically you could set your database to be replicated after 1 hour. So what it means is your primary database would be 1 hour further to your um, read replicas, or sorry, any other databases that you have pointed to. So how does it help is if there is any corruption, or if there is any uh, you know self-inflicted disaster or self-inflicted problems that has caused your database or data store, then it might not be replicated in all your um, data places, right? Data stores. So whenever someone, let's say someone has deleted the database, and that will not be reflected till 1 hour in the uh, your replicated databases. So you could use that delayed replication database as well. It's a strategy for disaster recovery. So there are basically two options: automated backups, where the data are copied to EBS volumes and it will be pushed to S3 as a data snapshot. So how this happens is, uh, basically, if you are moving it from your primary, it would go to, from your primary, the transaction logs are saved every 5 minutes to a S3. Or if you are moving, if you are doing an explicit snapshot store, then it would be saved from your secondary to EBS volume and then to S3. So there are many options that you could save. So basically this transaction log will help you go to any point in time recovery, where let's say they would give 35-day maximum retention. So till up to 35 days you could go back to any time stamp and take the uh, you know uh, data status of that at that particular time. So this would really help us in going backwards in time, where the data uh, would, you could back the data, or you could find the data um, with back, replaying backwards or rewinding your data backwards. So this is offered for all variants of RDS. So whenever you take a snapshot, we've already discussed that it is always incremental in nature, and your data volumes are, um, uh, every time you take the data, it is not the whole data, but incremented values or incremented blocks of data only. You can copy across accounts or across regions. So there is, as I said, there are two variants: automated backup and manual snapshots. So in automated backup, you could specify retention window, which is 7 days default, and you could uh, mat, you know, take it up to 35 days, which is maximum. And automated backups also support point in time recovery or restore. So basically, this can be achieved only through transaction logs. So what is transaction log? You might be wondering. So basically, uh, the transaction log is any transaction that happens between the system and the database would be captured in that log, and that would be saved. And if you play that uh, transaction log, your data will be replicated according to this timestamp. So it is something like, you know um, your migration file in Rails, where you might have made a lot of modifications. So based on the versions, the files keeps adding up, and all of these, whenever you run the migration for the first time, all of these migration changes happen one after the other, right? So that's how a transaction log works. So good. Basically, automated backups are good for disaster recovery, and if uh, you know if you are using manual snapshot, then it is basically you are requesting for it, and you will be charged for for the data that you are saving in your in S3. And there is nothing like point in time recovery for manual snapshot, because you are taking the data at that particular point of time and you are saving it in S3, right? So it is a safe snapshot. So if you have any data retention compliance, that would be great for manual snapshots. So there are some backup features as well, even though if you have, there is an option where even after deletion you can retain the backups. So even after deleting the backup, you could say that uh, the data has to be retained for a certain amount of time. Um, so you could you could also specify parameter groups value to restore, and you could copy incremental encrypted snapshots. So let's understand RDS in customer data center. So what it means is you could have RDS database in on-premise. So how this can be achieved is through VMware. So VMware provides vSphere clusters where you could launch your RDS like environment within your on-premise data center. So how this helps is RDS manages your your database administrative activities. It does automated patching or provisioning, and it gives you a console, um, you know and it gives you the same kind of environment what RDS gives you. It gives you read replicas on premises, and uh, CloudWatch. You could connect with CloudWatch and many other AWS provided services along with it. So basically, RDS would be in your data center if that is your compliance. So let's understand the security policies around or security and compliance around um, RDS. So you could set up your database instance in within a VPC, within the private um, subnet of your VPC if required. So, but the thing is, you might have to specify the network access rules for your database to be accessed if you are having a corporate address, a different address um, out of the VPC, or it could be somewhere with access by an application tier. You could you have to specify the access rules, something like this. This is an example for MySQL database. So we have added a port range as 3306. So it also provides IAM as governance. So you have to provide a certain, you know, um, policies to access the database. Only then you'll be allowed to access the database. And there is also something called as uh, encryption at rest, which is provided by Amazon RDS as an option. If you choose to encrypt the data within the database, then you might have to do it with AWS Key Management Service, where it provides two-tier key hierarchy if required. Like you get customer managed master key and data keys. So basically, you could see data keys are uh, keys which are specific to your different database instances, and these database keys are encrypted by one custom master key. So basically, what this means is internally, if you want to understand how it works, or if you want to know how it works, the database keys are, let's say it's just a string where these keys are encrypted by customer master key, and whenever you want to access this instance you need the data key, but customer manage master key can only decrypt this data key to access the RDS instance, specific RDS instance. So if you go to KMS and KMS documentation and read more about customer master keys and data keys, you would understand how it works. And there is a white paper on this as well, so you could go and refer that. But basically, the crux of it is data keys are designed to access, designed for a particular database instance, and customer master keys are uh, keys which encrypts the keys, basically. So here, in this case, you would get two-tier key encryption uh, security. So your database are monitored using CloudWatch. You can set an alarm. There is also enhanced monitoring, and you can integrate it with third-party monitoring tool. You can, if you are, let's say you are trying to uh, use for development and testing environments, you could actually stop your database, and you can start it back whenever you want. But if it is stopped for more than 7 days, AWS would restart it, and they claim that they do that to update database or apply any patches, database patches, or any maintenance activity. Once started, you might have to stop that database again, but for every 7 days, it would be restarted. You could actually build a trigger around it. You can automate the process of shutting it down as well. So um, or you might have to do it manually. uh, Amazon or AWS by themselves, once they start, after 7 days they don't stop the database. So to understand some of the best practices of these, AWS themselves will provide uh, a feature called recommendations, where it is available in the menu section of RDS, where when you click on that, it would say, uh, what are the best practices guidelines for analyzing your resources. By analyzing your resources, some of the examples are engine version outdation, if there are any maintenance pending, or if there is any automated backup disabled. If you want to, the recommended option is always to enable it. And if there is, if you have any enhanced monitoring disabled or encryption disabled, these are just recommendations. You don't need to enable if you are aware about it, if you are aware of it. These are just recommendations for the best practices. So there is another cloud native database, that is Aurora. It is compatible with MySQL and PostgreSQL relation databases. If you have MySQL or PostgreSQL in your on-premise database, we Amazon AWS provides a variety of third-party tools, or and also its homegrown database migration service tool to move it to Aurora. This provides performance and availability of commercial database at one tenth of the cost of the commercial database. I'm really sorry. So the performance and scalability that they claim is they provide five times the MySQL or three times the PostgreSQL standards, and they scale out up to 15 read replicas. They are highly available and durable. They do continuous backup to S3, and they claim they make 6 copies of your data. So that is the durability level that they are providing. So basically, they are highly secure. They give network isolation, encryption, trust, and transit. They are and also there is no hardware provisioning required, and software patching, setup, and configurations or backups required. It is all managed by Aurora. So Amazon Aurora has basically three endpoints. So it's cluster endpoint, reader endpoint, and instance endpoint. Cluster is basically the primary instance. It points to primary instance, and reader endpoints points to reader instances. Reader instances can only be used for reads. You cannot write on uh, reader endpoints. So you can choose between the cluster and individual instances. So if you're choosing individual instance endpoint, individual instance, then you would get instance endpoint, and if you're using cluster variant, you would get cluster endpoint and reader endpoint both. There is also another variant of Aurora where you could choose your Aurora to be serverless. So what the serverless offers is it gives you the capability, or it gives you the option to not select a particular not select a limit to the computation capacity. It would auto scale based on the resource, and because of this it could provide uh, better pricing compared to fixed servers. And what this would give you is but the uh, you always have the control to select the minimum and maximum capacity units. So capacity units are uh, basically called as ACUs here, Aurora capacity units, and one ACUs are almost equal to 2 GB of memory. The pricing is one ACU is almost 6 cents per hour. So you also have scaling capability and also automatic pause and resume, which is a nice feature here, because you are not calculated for uh, the computation, or uh, your computation size when your system when there is no request, or when you have no request hitting to that database for at least 5 minutes. So the default is 5 minutes. So whenever it reaches the 5 minutes time and there is no request being hit there, then your server would be, your server would go down and you would not be charged for the computation. You will be charged only for the storage. So basically, they have separated in the database. They have separated the database into two components: computation and storage. So you would not be charged for computation here. So database migration engine or the service basically helps you to migrate the on-premise data to AWS, and it will also help not just from on-premise to AWS but also between AWS databases, whichever is there in the cloud at present, right? So you could also use the database migration service for automated schema conversion. If you have a table and if you are thinking about converting that table into a different format, you could use a database migration service to do that. You could also use this for data replication, which helps you to get the zero downtime migration. So there are mainly three use cases to if you are looking for modernizing your application to move between your on-premise to AWS cloud or different databases. You could use this DMS tool to do that. You could whenever you want to migrate from um, you know your database to a different set of databases. Like let's say if you want to migrate from RDS to Redshift, you could use a database migration service. And also whenever you want to do a cross-region replication, then you could use the DMS service as well. Let's see how what are the main benefits of it. So these are not expensive, firstly, mainly. So these these are free if you are migrating to Aurora, Redshift, or DynamoDB. If you are uh, if you have workload from any variant, whether it is AWS or on-premises or anywhere, so DMS comes out free for migrating into Aurora, Redshift, or Dynamo. But you're charged as low as $3 for uh, per terabyte for other migrations. So this is mainly beneficial um, if you are looking for uh, avoid to lock-ins within your databases, and it provides you no downtime uh, for your database engines. So there are heterogeneous you know migration and homogeneous migration. So if you want to use move between Oracle to another Oracle system, so from on-premise Oracle to AWS Oracle provider, so you could use DMS or you could use uh, heterogeneous would come when if you're moving from a SQL server to Amazon or Oracle to S3, still you could use the DMS. So RDS also has come up with something called as performance insights. What it does is it gives you the insights of how the database is performing. You could identify the bottlenecks. You could identify the average active sessions, how the DB load is happening, how whether it's load is on CPU or out of CPU, how it is performing, what for the different time frames. And you could just enable it or disable the problem performance insights, and you could retain the data up to 2 years. This also supports cloud formation. So whenever you're writing a cloud formation template, you could enable performance insights through a cloud formation template. So that's all was there for from when it comes to Amazon RDS and databases. So let's quickly move to Amazon Kinesis and how uh, Kinesis, what this Amazon Kinesis does, and what it really means, right? So let's move on and understand what Kinesis is all about. So Kinesis is basically used when you want to ingest, process, and analyze real-time streaming data. So you could, you could get timely insights, or you could react to those data quickly in real time. These are fully managed systems and they scale automatically. And some of the capabilities that are provided by Amazon Kinesis platforms are uh, basically Kinesis video streams, Kinesis data streams, data firehouse, and data analytics. So here is an example, or a graph. Sorry, it's a graph. What it depicts is, on the left side, it talks about the value of the data. The y quadrant is y axis is value of the data, and the x axis talks about, or it's about the time, uh, from seconds to months and years, right? So as and when the time is more critical um, in decision making, then the value of the data would be more in the business, which means that whenever there is a real time data which is actionable, it is more valuable than the data which is historical, right? So this real time data are part of the streaming data, and the historical data would be mostly a batch data. So what this means is, the data which is more valuable is draws all the business attention, and streaming data are more important when it comes to uh, real-time metrics and analytics, and real-time data processing. So let's see the difference between batch processing and stream processing. So batch processing, basically the logs could be hourly, weekly, or even monthly, and there could be daily website clickstream, and even the fraud report. But when it comes to real time, uh, it could be real time metrics or click streams analysis, which could be drawn into the dashboard somewhere, or real time fraud detection can happen in stream processing. There are some use cases where uh, whenever you're considering a millisecond use case, then it would be, an example would be messaging between microservices, and uh, it could be response analytics from web or mobile applications. If you're looking for data which is ingested, and the value of that would be in seconds, then it could be log ingestion or IoT device maintenance kind of workload. And if the data is valuable even after minutes, then it would be mostly streaming ETL into data lakes or data warehouses, right? So for all these use cases, you could still use streaming, which is provided by Kinesis. Some of the examples I have just quoted here. So basically, when you enable real time analytics, you would have a source, and source would stream the data into, you have a lot of we get a lot of stream ingestion components. It could be SDKs, it could be um, any agents which is pulling the data from your EC2 instances or any other system. Uh, it could be it could be any system or any component which is ingesting the data into stream. It could also be uh, KPL in this producer library. You could use producer library, kinesis producer library to ingest data into the stream, and there is a stream storage. And stream, once the data is stored in stream, it has to be processed using stream processing. And once the processing done, it has to be pushed into a particular destination. So AWS Kinesis, what it offers is AWS data streams for collecting the data, AWS Firehose for pushing the data to a particular destination, AWS data analytics to transform the data for stream processing. As I said, there are many sources that you could have. It starts from mobile apps to smart buildings. You could have, data producers and streaming service and data consumers. And when it comes to ingestion, it can be SDK, it could be producer libraries or SDKs, mobile SDKs or Kinesis agents, and it can also be some of the AWS service integrated. It could be CloudWatch logs or events which are triggered. It could all be fed into the stream, and stream would store those data, and it could be processed and it could be delivered to a particular location. There are also third party offerings here as well. So to understand the Kinesis data stream is basically divided into shards, and data is stored in shards. Shard is basically the throughput unit of the data stream. So shard is, you could say, it's a logical entity or unit where you would set the throughput limit, and you could actually add the data, store the data in shard. You could add or remove shards dynamically, and um, data records are stored in the shards. So whenever you're storing data records, it's basically it's the unit of data that is stored in the stream, right? So uh, it contains sequence numbers, partition keys, and data blob. So these are the main three components that any data record would contain, and each data record can be maximum of 1 MB size, and this 1 MB would comprise all. It should contain all like data blob, partition key, and sequence number. So partition key is basically specified by the producer. In this case, let's say we have a Kinesis producer library, and the producer library would generate this partition key to place the data record in the respective shards. So if you have set 10 shards, and the producer library generates the partition key based on the uh, data and the shards for the respective shards. So every time it is generated, it goes into the particular shard based on the partition key. So there is also sequence number that is generated, and this is uniquely identified. This is a unique ID for every data record, and as the time increases over the time, this sequence number uh, also increases. So you would get for every shard you would get 1 MB of write per second and 2 MB of read per second, and up to 1000 put operations. That is, per shard you can add up to 10,000 records or 1 GB of data inside the shard. Yeah, per second. This is, sorry, this is per second. Yeah, no, per second. Yeah, this is up. So the records size. Uh, so this is per shard, right? So it could go. You could have multiple shards and you could write it. So what was your question? I'm sorry, I didn't understand. Correct. Okay, put is like adding data into the shard. Put is not updation. Okay, so in kinesis world there is nothing like update actually. Okay, so everything you are trying to put into the shard, into the stream, right? No, no, no. So when I say 1 MB of write, it is writing into the stream, right? This put means it is also writing, but it is on a record level. So I'm just saying you could add, okay, you could forget this put, but the operation is called put, okay? But you could always replace this put with add. You could say 10,000 records can be added in one put operation. Okay, when I say write, it is again, it is at a network level. Okay, this is at an application level, uh, right? So per shard you could write it to 1 MB per second. Correct, that is the capability to write into the stream. To read from the stream you can read up to 2 Mbps per shard. Okay, if you have 10 shard you can read up, you can, the read capacity would be 20 Mbps. Sorry, yeah, but 20 Mbps, but it is individual to the shard, right? 2 Mbps per shard. So got it, right? So I think I made a mistake here. It is not 1 Gbps. I think I told 1 Gbps. I'm very sorry. That's what made you even more confused state, right? So it is not 1 Gbps. I'm very sorry. So you could write it. You could write up to 1,000 records into the shard, but that the whole write can be maximum of the whole 10,000. Sorry, the whole 1,000 records size can be maximum of 1 MB. Okay, so there can be 10,000 operations, but maximum of uh, the whole aggregate would be maximum of 1 MB. Okay. So kinesis is charged by shard hours, and basically for how many number of shard you have into the number of hours that is being used. you'll be charged. And there is something called as put payload unit, which is 25 kb. And if you are putting your you know put operation for less than 25, let's say if your put payload is less than 25, it will be let's say if you have 20 kb put payload, but still that would be considered as 25 kb payload, because the unit itself is a 25 kb. So there is a data retention period is from 1 day to 7 days. And they have come up with enhanced fan out capability, which could incur hourly charges. So what this enhanced fan out does is, if you want to connect with the stream, you have more than one consumer, and let's say that you have 10 consumers, and 10 consumer want to consume the stream data continuously, parallelly, then the 2 MB throughput is not sufficient, right? So what this kinesis stream does is, it has provided a capability to read the data from the stream with this enable fan out option, where each consumer gets 2 MB PSP or 2 MB read capability. If you don't enable this option, you would get combined all your consumers, you would get maximum up to 2 Mbps or 2 MB per shard, right? So enhanced fan out is an option if you have more consumers per shard. So basically, if you are not enabled, enhanced fan out, your get calls reading capability is free and data transfer is also free. But Kinesis doesn't come under a free tier. So there are many libraries that are provided by um, you know available out there, and AWS provides two libraries for stream processing, that is producer library and client library. And producer library is used for ingesting data into the stream. Uh, Kinesis client library is used to read the data from the stream, uh, and it uses basically it handles sharding and auto scaling if the client library is part of EC2 instances. Um, it can also track shards and its iterators. So shard iterators are nothing but a pointer. You can say pointer in the shard, where it points to the latest uh, or the newest data that you have that you need to retrieve from. So if there is any consumer and it is pointing, if you are consuming data and you have consumed somewhere around 50% of the data, the pointer has to point to the 50th percentage of your data, right? So that's what the shard iterator does. So there will be many shard iterators uh, per KCL. So this is a very high level representation of how it works. So there is, while ingesting, you get somewhere around 1 MB per second speed, and there could be 10,000 records per second. Sorry, 1,000 records per second, with a maximum for each chart. Uh, the combined all 1,000 record can be maximum of 1 MB. So it can be maximum of 5 reads, and there can be maximum of 2 MB uh, 2 MB throughput for read, unless if you enable enhanced fan out. If you enable enhanced fan out, you would get average latency of 70 milliseconds against the standard latency of 200 milliseconds. So it is a premium service that is offered. So the consumers can be uh, data analytics, EMR, EC2 instances, AWS Lambda. So as I said, Firehose is for you know uh, basically directing the data um, or directing the data from the stream to a particular destination. So it continuously loads streaming data into S3 or Analytics or Redshift or search service, Elasticsearch service, right? So you could use Firehose to direct your data to a particular destination. If you are also looking for a small transformation with the help of Lambda that you want to transform, then you could use Firehose also. So you could use uh, you know Firehose to uh, Firehose along with the Lambda to do a small transformation and push it to S3 or Redshift or Elasticsearch. This comes with a near real-time access. So they have also you can now you can also push the Firehose data to Splunk, Apache Splunk, if you heard about it. So Firehose has a different pricing model. So um, data is ingested into the Firehose, then it is directed towards a particular destination, right? So it depends on basically the number of data records that has been inserted into this, and size of the data records rounded up to 5 kb. So if it is like 38 kb or 36 kb, it would be rounded to 40 kb, and the data whichever is stored in RDS, sorry, in Firehose will be retained for maximum of 24 hours. So what it means is anything which is coming into Firehose, you have to uh, direct the data into the destination. If there is any buffer data or if your destination is not available, it can retain the data up to 24 hours. So some of if you are wondering the database stream versus data Firehouse, both have a similar use cases, but uh, data streams stores the data, incoming data, and it provides a stream uh, to be processed by different stream processing engines, wherein uh, data firehose actually you could apply some of the basic analytics or some of the calculations or some of the transformations inside the firehose, and you could direct that into different destinations. So stream processing engines, there are many stream processing engines. uh, Kinesis data analytics is one of them. There are lot many third party vendors. You could use just the lambda to process the stream, and you can actually connect the lambda to directly to um, kinesis data stream and process it. But what happens with the lambda is maximum one lambda can be connected to a shard. So you can get maximum of uh, one lambda connected to shard, and there can't be a scalable improvement or auto scaling in terms of a one to many shard versus lambda. So when it comes to data analytics, it analyzes the streaming data using SQL, and it supports both querying, kinesis stream and fire hose, and uh, it could map incoming stream data to scheme, which means that if the data is in a different schema, it could apply um, a completely different schema altogether. If you have an unstructured data, you could add the schema to make the data structured data and feed it to uh, you know um, Redshift, and you could do a lot of analytics with it. So basically, it can be used to continuously detect anomalies, time series analysis, filtering, aggregation, or any enrichment in the data. Um, you could use it for a lot of basically analytic purpose, and you could also, once the analytics is processed, or if you have any transformation, once that is done, you could actually redirect it back to the kinesis stream. So you could pull the data from the kinesis stream, do some analytics in the kinesis analytics engine or a service, and put back the data into a new kinesis stream. So this might be another use case where you want to do some transformation with the help of SQL tools, SQL language, right? So, so there are three common scenarios where you could use that, right? That is, deliver data to analytics tool faster and cheaper. So streaming, ingest, transformation, load, continuous metric generation, or uh, actionable insights. If you want to find out uh, more analytics insights about the data, then you could use it. So combined all the kinesis services, you could this is the architecture that could be built: web analytics and leaderboard. This is an example of a, a app where it is ingesting the data into the kinesis stream, and the kinesis stream uh, contains the data, I'm very sorry, the data of users who are part of this application. And what we are trying to find out here is, we will compute the top 10 users of this application with the help of data analytics, and we would feed that to lambda, and lambda would feed that to dynamodb table. So if the application wants to know their 10 top users on real time, this whole pipeline could get us there. So you could easily build this in your with your with your account. This this example you could try and achieve it actually. So this is an example where we are monitoring IoT devices, and it is IoT devices is ingesting the data into Kinesis data stream, and there are analytics which are computing average temperature every second the data is ingested, and with the help of Lambda we are pushing it to DynamoDB instances. There is another example. There is another example of analyzing event logs. So what we are trying to do here is, we are trying to move the Kinesis data firehose into the S3 bucket. Then it is also moving the data into the analytics, where it does some computational metrics, and it would feed it to firehose, and firehose feeds it to Lambda. Then it also firehose also you know uh, ingest the data, give a destination to S3 bucket for process data, and the lambda would take it to DynamoDB tables, and the chart in your app or probably this any application, it would find the data in real time. So this is again an example of log ingestion where kinesis stream is pulled from Firehose. So you could see that stream has uh, two different consumers, right? One is analytics and one is um, Firehose. So Firehose pulls the data. It would always, whenever it is pulling the data, the uh, shard iterator would mark to the right, uh, record that it has to be fetched, and it could fetch the data which is unread by Kinesis data Firehose, and Firehose would feed the data to Elasticsearch for if you want to find out any real-time analytics or searching for searching purpose. It also can move it to S3, and you could use Athena to find out the data inside S3. So this is also a classic example of uh, using Kinesis and um, streaming platform. This is just a uh, example architecture. If you are building completely out of Kinesis, and you would have mobile data as a source, you have stream ingestion systems, you have Kinesis agents, producer libraries or SDKs. You could push that data into stream, and you have real-time applications which can be um, which can read the data from the stream, and you have Firehose which could be used for ETL purposes, and you could feed or you could move the data to a particular destination. It could be S3, Redshift, or Cloud Search, Elasticsearch and Splunk. Yeah. So these were the things that I had in mind to talk about today. So, if possible, try to go through these architectures, and there are a lot many architectures examples available outside. So try to understand and try to know how we could use different services for different purposes, right? So we had databases for a particular purpose, and there are a lot of services for a particular purpose to be used, right? So we need to identify the right tool for the right requirement or right purpose, right? So try to go through more and more um, you know architectures that would give us more understanding about when to use what, right? So there are a lot many if you see here in this case, there are Kinesis agents which are there as part of EC2 instances, and there are Kinesis producer library themselves or SDK. So which one to choose is something which we have to practically experience it. So try to build it with a very small workloads. Have you can actually, there are sample data which is provided by Kinesis in their website. So please try to get the sample data for your processing, and you could also feed your own set of data, but the sample data that is provided by Kinesis website really helps you to move forward and start building uh, this. And also I showed another example of uh, different, a bookstore example. Try to you try to use the cloud formation template and uh, build that example within your account. That might give you some more insights about um, the different databases and how they work um, when you use it, right? So you could understand better. Yeah, so that is all I had for today. Mm,